When writing code within the .NET framework and a C# application, it's important that you're aware of how the compiler and how the computer handle and manage the resources required by your application. We're going to take a look at garbage collection and the garbage collector within the .NET framework. It's kind of an odd name for a way of managing the memory resources in a computer, but garbage collection essentially means that the .NET framework, the compiler, and the operating system are handling resources that are no longer required. So much like you would throw away something into the garbage at home when you no longer need it, we're going to do the same thing with our data types within the .NET framework. So remember, every type in your application is allocated memory in the computer. The garbage collection will deal with the reference types, which are the classes or the objects that we create within our applications themselves. Reference types remain in scope until they are no longer needed. That's in contrast to value types, because value types are managed and stored on the stack. They go in and out of scope automatically as the functions or the areas of the application in which they're used go in and out of scope. But reference types may remain in scope even though an application function no longer needs that object. There may still be another reference to it somewhere else in the application. So they will continue to occupy memory on the heap as long as they are in scope. C and C++ developers had to release memory resources themselves. So each time they created an object in their code, they had to monitor and manage the pointers or references to those actual resources or those objects within the code. And then when they were no longer required, they had to destroy them. If they didn't, this is what created memory leaks within their application. Fortunately for you, developing the .NET world, the garbage collector will handle this task for you. So how does it work? Well, the garbage collector checks for objects on the heap that are no longer referenced. And the way it does that is as soon as your application starts, the garbage collector starts to run, and it assumes that all objects in memory on the heap, are actually garbage. But it doesn't necessarily release everything at startup, though, because your application may be requiring those objects at the time. So instead, what it does is it walks the route of all the objects, and it checks for references to other objects and references to the objects it's looking at. And then once it finds all of the references, it will generate a graph of all objects that can be collected. Any object that can be collected is one that no longer has a reference to it. We're assuming it's no longer being used in the application. From a performance perspective, the garbage collector will exact a performance hit on your application because it has to walk that stack of objects that are existing in your code. But it will attempt to do this when the application is not running or not performing a lot of tasks. So in other words, when the computer has freed up some resources for the garbage collector to run. It doesn't run all the time, only when the system has actual available resources for the garbage collector to execute. The garbage collector will be invoked automatically when the heap is full, and as a result, you should never receive an out-of-memory exception. So in other words, we should never run out of heap memory with the garbage collector running for all of our managed resources. There is a potential that unmanaged resources may cause this problem, but realistically, we should never see an out-of-memory exception with the garbage collector. So how do we use it? Well, one of the things that I'm going to tell you about in this course is let the garbage collector basically run by itself. Let the framework handle the GC execution. Certainly, you can manage the garbage collector yourself. You can call gc.collect to do this, but it is something known as non-deterministic. Basically, it means that if you call gc collect, it doesn't mean that the garbage collector is immediately going to run just because you called it. The .NET framework still manages the garbage collector, and it's fully capable of knowing when it should and should not run gc.collect. GC will only run when the system resources permit, and this is why calling gc.collect doesn't mean it's necessarily going to kick in and start executing at that point in time. But what it does do when you call gc.collect or when the garbage collector runs itself is it supports something known as a finalization phase for your objects. And what this means is it gives your object the ability to clean up after itself. And we can do that through something called a finalize method. You can write a finalize method in your object yourself for cleaning up, or you don't have to write the finalize method and your objects will simply go out of scope and be released. By writing code in the finalize method, you can release some resources, perhaps such as open database connections or open files. I didn't really show you any code in here because what I want you to focus on is the fact that the garbage collector is handled and managed by the .NET framework. And as a beginning C# programmer, you shouldn't be messing around with the garbage collector. Let it do its job. Let it take care of managing the resources for you. And as you gain more experience with the .NET framework, and managing the resources, you can start writing finalized methods yourself and cleaning up your code within your application.